Alright, welcome back to JavaScript The Basics. In this section, we're going to look at functional programming. This will be a primer on what functional programming is and give you a taste of how it is used in JavaScript. You won't learn functional programming overnight, but you can begin to see the benefits and results of it immediately. One of the characteristics of JavaScript that makes it well suited for functional programming is the fact that it can accept higher order functions. A higher order function is a function that can take another function as an argument or that returns a function as a result. Functional programming is just how it sounds, programming with functions. In JavaScript, functions are objects. Functions are values. That means that functions can be passed along to other functions. Eric Elliott explains functional programming this way when he says that functional programming glossaries contain a large number of large words. But at its core, the essence of functional programming is really very simple. Programs are built mostly with a handful of very small, very reusable, very predictable pure functions. Now you probably want to know what pure functions are. For now, concretely, that means a pure function always returns the same result given the same parameters. A pure function is a function in which, given the same input, will always return the same output, produces no side effects, and relies on no external state. Don't worry if that is going a bit over your head. Remember, we're learning a new language, and to do that you have to hear people talk in ways that you might not be familiar with or comprehend everything that's being said. This section of lessons will be about getting a grasp on how higher order functions work, so some of these words will begin to make more sense. To get started, we'll look at Twitter. No, we aren't going to talk about their technology stack, algorithms, or anything like that, but a tweet that I liked. It was by Steven Luschner. He used some emojis to illustrate functional programming with map, filter, and reduce, which are the three array methods we will turn our attention to in attempting to understand functional programming over the next few lessons. Let's look at the image. We have an image with map, filter, and reduce. To map belongs an array of three images: corn, cow, and chicken. The word map itself is a method or a function on an array. Then we have the word cook representing a function as well, as if each item is going to go through a cook function. Remember, a function is like a button. It is a chunk of code that we can apply over and over again. A function is a process which takes some input, called arguments, and produces some output, called a return value. So within the function or method map that is attached to an array, we are going to pass another method. It will work on each element of the array, and when the corn is cooked, we have popcorn. When the cow is cooked, we have a hamburger, and when the chicken is cooked, we have an egg. So map is a method that worked on each item of the array and returned a new array in which each element went through a function. Next, we have the filter method on an array. Our array this time has popcorn, hamburger, and eggs. This time, each element of an array is going to be ran through a sort of true and false filter for whatever specifics we want to name. In this case, it is a filter called isVegetarian, and it's a function. It will return a new array with popcorn and eggs. Yes, some vegetarians might not consume eggs, but this imaginary vegetarian does. So it returns an array in which every element has been evaluated true or false, and the true values are returned to a new array. Third, we have the reduce method. This is the most complex, and we'll spend a good chunk of time breaking it down and explaining it. While map and filter have very specific uses, reduce has lots of customizable flexibility. But for our illustration, we'll look at a simple execution of it that shows that reduce will go through our array and run our elements through a function that will return one value. In this case, both popcorn and eggs have the same final destination in our digestive tract. Functional programming and higher order functions are good for composition, putting one function into another function, putting smaller functions into bigger functions. Let's go ahead and begin our functional programming analysis with filter. Filter is a method, aka a function on arrays. It accepts another function as its argument that will return a new array. Previously, we have inserted strings, numbers, and booleans as arguments in our functions. Now we are passing functions as arguments. For each item, we will have a callback function. Filter calls a provided callback function once for each element in an array, and constructs a new array of all the values for which callback returns a value that coerces to true. The original array is left untouched. Let's look at the syntax. We have our array, then we have the filter method, then within that filter, we are passing it a function as an argument. This is what makes something functional programming, passing a function to a function as an argument. That function then receives a parameter for the current value of the element. This is required. We then run the code block on the current value, and if it is true, we return it to the new array. Alright, thanks for hanging on for so long. We are finally ready to get into some code. Let's create an array with test scores. We'll declare a variable called test scores and assign it values of 92, 87, 54, 63, 75, and 59. Let's create a function expression called passing test. We'll declare a variable called passing test. We'll then assign it the value of an anonymous function. We'll give it a parameter of test representing the current element in the array. We'll then enter into a code block and return a boolean of true or false in regards to whether a test has a value greater than 60. So this is our function we're going to use as an argument. Let's go ahead and declare a variable called graduation. This array will contain all the passing tests. That means the student is graduating. We'll simply run the filter method on our array. Within the parentheses, we will put in our argument of the function expression that will run on every element in the array. It will return a true or false value for each element and create a new array in which only the elements that are true will find themselves in the new array. Another way that we can write this out instead of putting our function expression in as an argument is we can just write out our function within the parameter, and the result of both are the same. Our test scores array has not been mutated, it is exactly the same. We now have a new array. What if we didn't use filter? How do we go about getting the same desired result from our test scores array? Let's go ahead and look at the code that it would take to accomplish this using a for loop. The first thing we will do is create an array called graduation. that we are going to fill with values. We'll then use a for loop to go through each element in the array, starting with the first element. Our test condition will be as long as our current value for our counter is less than the array length. We'll dive into the code block and create a conditional statement. We will evaluate an expression. If test scores of index 0, which is 92, is greater than 60, in our code block, we will now access our graduation array that we created above. We'll use the push method that pushes our value to the end of the array. At this point, our value for our current element is 92, so we push that onto the end of our array. We then repeat the process again and again to fill up our array with values greater than 60. Now, let's look at these two side by side. Clear code, less code, and easy to keep bug-free. I hope you're beginning to see the benefits of functional programming. Alright, thanks for taking this first look with me at functional programming in JavaScript. We'll see you in the lab to begin to put into practice what we have learned.